Hello, this is Susan Poss again. We're still working in section 10.1. First part of 10.1, remember we worked on the square root method, and this is the second method in here. It's called completing the square. So what we're going to be doing with this is looking at creating what are called perfect square trinomials. That's what these are. These are all perfect square trinomials because they all factor in a special way so that the two factors turn out to be the same binomials, and we can write it as parentheses and then the binomial on the inside squared. So if you'll look at each one of these, you'll see that they each factor and follow that same pattern. All right, so our goal is going to be to generate an expression that looks like that. We're looking for a binomial in parentheses squared so that we can back up and use our square root property that we were using in the previous video. So here's an example of another trinomial square. You see how I've factored it, both x plus 3, and then writing that x plus 3 quantity in parentheses squared. So that's our goal. So how do we get there if we only know the first two terms and we're trying to figure out what the third term in the trinomial needs to be? So there's a little pattern to these. You want to take half of the coefficient on the first degree term. All right, so that's a mouthful. In this particular problem, the coefficient on the first degree term is this positive 2. So I take half of that and I get 1. So that's the completion of the first step. The second step is to take that result and square it. So if I take 1 and square it, I get 1. That is what I add to the trinomial, so that now if I tried, let me run up here, if I tried to take this trinomial and factor it, you see that it could be written as y plus 1 quantity squared. And remember, that was our goal, to get a parentheses with a binomial inside and then have it be squared. So let's run through the same two steps over here. We're going to take half of the coefficient on the first degree term, and we're going to take that result and we're going to square it, and that's what we'll add into this last position in the trinomial so that it creates a situation that could be factored to reach our goal of binomial in parentheses squared. So those two are pretty easy because those were nice even numbers. So I'm going to split these exercises into even coefficients on the first degree, and then we'll go later to odd coefficients. So here is an example of odd coefficients. So again, remember the steps. I'm going to be taking 1/2 of the coefficient on the first degree term. I'm going to take that result, square that result, and that's what we will put into this position. So one more quick one. 1/2 of the coefficient on the first degree term, and then take that result, square it, and that's what we will add into this third position. All right, so what are we going to do with that process? We're going to use that method called completing the square to solve these second-degree equations. So again, here's the first category. I'm looking at the ones, first of all, that have even numbers on those middle term coefficients. Again, those are a little easier. So what you're going to see me do is make sure I have it arranged in a particular order. So the arrangement steps are right here. I want the squared term and the first degree term on the left side of the equals mark. I want the constant on the right side of the equals mark. And you're going to notice how I'm leaving a spot after that 6y. That's where I'm going to complete the square. I've got the constant -8 on the right. I've got the second degree and the first degree terms on the left. So this is where I'm going to do 1/2 of the coefficient on the first degree term squared, and I'm going to add, let me change the color so that's emphasized, we're going to add 9 to the left, and to maintain balance we're also going to add 9 to the right. So I'm going to factor the left-hand side, and you can go, after you've practiced these, you'll be able to immediately go to our goal, which was y plus 3 in parentheses squared. Over on the right-hand side, I'm just doing the arithmetic for now. -8, +9 gives me 1. This is where we come up with our square root method, which we practiced on the last video. So take the square root of each side. Square root of y plus 3 quantity squared is y plus 3. The square root of 1, both positive and negative, is 1. And solving here, remember we're expecting 2 answers. I don't know how that happens. So here are my 2 answers. -3 plus 1 is -2. -3 minus 1 is -4. Okay, so solving by completing the square, I've got a few little steps that you have to remember, but I find that students, once they master this process, they like it as one of their more easy, one of the easier ones to work with. All right, so let's do one more example. I think this is a good one for me to work, and then we'll stop this part. Remember, the arrangement is important. You want the second and the first degree terms on the left. So I've got a little bit of problem here. I've got the first degree term sitting on the right. That's not where I want it. So first we'll add 6x to both sides. Oh, and I think I'll go ahead and leave a little space in there and leave the +1 constant over on the other side. So I have it arranged the way I like it. Now I'm going through my little completing the square step. So I take 1/2 of the coefficient on the first degree term. I take that result and square it. And that is what I add to both sides. Remember, that's what I put in red on the previous one. So if you add 9 to one side, you have to maintain the balance and add 9 to the other side. So the first side, I'm going to factor it. And remember, I deliberately put that +9 in there so that it would factor in this special way, our goal. And then I'm going to do the arithmetic over on the right-hand side, 9 plus 1. This is where you take the square root of both sides. And when you take the square root of the 10, you've got to remember both the positive and the negative root, because again, we're expecting 2 answers because this was a second degree equation to start with. So on second degree equations, you're expecting at most 2 answers. All right, so subtracting 3, here are my two answers. So there's a negative 3 plus the square root of 10, and there is also a negative 3 minus the square root of 10. So here are my two solutions to my second degree equation. All right, I think that's all I want to do right there. Oh, I did want to show you how to arrange this one. I'm not going to work it, but I'll show you how to arrange it. You want the second degree term on the left, you want the first degree term on the left, and you want the constant term on the right. So you see that both the constant and the first degree terms had to move here in order for me to get it into the proper arrangement. And then quickly, I'll go this far and then I'll stop. When you take half of negative 10, you get negative 5. When you take negative 5 and square, you get positive 25. And that positive 25 is what you add on to both sides. So quickly, this is going to factor like this. Over here, I'm working, I think, with a 12. Oh yeah, let me go ahead and finish this one to remind you about something. So I'm taking the square root of each side, positive and negative square root over here. And this is what I wanted to remind you. When you work with 12, I'm going to split this up into 4 times 3 in order to simplify it, because I can take the square root of 4. So this will be 2 times the square root of 3. So here are my answers. I should come up with a 5 plus 2 times the square root of 3, and I should come up with a 5 minus 2 times the square root of 3. They're my two solutions. All right, that's a good place to stop.